the hard disk. So I'll sit down one place and write the software, and then I have one technician with me. I always hire one technician because when I make a change, okay, I ask technician, can you go check, did it happen or not? You know, did the change happen or not? Because there's a long software, you're talking about millions of lines of codes. Yeah, I'm making changes to it, and then wait, just before I carry on. Samad say I need to take a screenshot of your attendance. That is your attendance. Okay. 1, 2, 3, 4, 5, 6. Hey, I got 8. Oh, 2 more to come. Okay, never mind. Never mind. I'll just take the screenshot first. 1, 2, 3, 4. Who is not here? Camelia is not here. Georgina, you're close to Camelia, right? Can you contact her? So I got to get a screenshot, and that is your attendance for your semester. That's Samad's rule. So it's in every class like that. So that's how they can tell you attend a class or not. If you don't attend a class beyond certain number of class, you can't take your final exam. You know, that's a UCDS rule from long ago. Okay, 1, 2, 3, 4, 5, 6, 7. 7 I got. Who is missing? Dalton. Wait a minute. Yeah, Dalton is not here. I hope someone can contact Dalton. Anyway, I'll take the attendance a bit later because this affects you. Remember this? There was one student got kicked out last semester. I think you all know about it, right? And the main reason was because he didn't attend any class at all for 2 classes, and he got kicked out last sem. Okay. So bad grades is not the reason they kick out. It's mainly because of attendance. If you don't attend class, they will kick out. Okay. 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 2, 3, 4, 5, 6, 7. Oh yeah, Delta is not here. I don't have Deltas. Yeah, maybe I should code Delta. Delta. Eight, 6, 5. 8, 6, 5. 6, 9, 6, 7. Hello, Delton. Yeah, I have class now. You didn't sign in yet, huh? Right. Just wait for Delton because I need to get a screenshot. I picked. Okay, no. Okay, like I said, let me show you the paper also. Okay. Okay, this is my paper. I just wrote it in one day. Of course, I did all the work. So, I mean, I've been working on this project for, I don't know, 2 years plus. So, of course, I did all the work. So, it's easy for the knowledge, right? You have to put you see, I put some calculations. Basically, what I'm saying here is that you see, we for 1 year, practically 1 year, Cisco didn't give us the power, and the alasan was my circuit was not good enough. Okay, so we keep improving. Listen to them. I listen to them every time they tell me to do one thing. I go and do, and then they reject. Until it is this level, baru they simpan the power. Okay, simpan power means, you see, I paid them 7,002. You know, it's not a cheap thing to get 3-phase. You see, this kampung already has 3-phase wiring. That means the 4 wires, right? In normal housing estate, you see 5 wires. Okay. Okay. So in normal housing estate, you see it like this. But in a kampung, there's only 4 wires. Okay, because they don't have the switch wire. Okay, the switch wire is basically the street lamp wire. I don't know why they call it switch wire. I asked, because I teach a lot of Cisco staff, few hundreds lah, and I asked them also why they call it switch wire. No one can answer. Boss check up itu, we just call out. Okay, it should. I mean, if it's street lamp wire, it's so much easier, right? That wire is just to power the street lamp. Okay, so in housing estate, you see 5 wires, but in this kampung, there's 4 wires. That means red, yellow, blue, neutral. But coming down to every house is only 2 wires. Okay, so it could be red, okay, and neutral. Okay, could be red, neutral. You can check lah. You can go out your house today and see what phase is your house. Like my house is red phase. Some people yellow, some people blue. Okay, so different houses will have different phases. But of course, there are richer people. I think some of you are richer people. You have all three phase in your house, but it doesn't mean your house is your equipment is 3-phase. Okay, it's just that your front hall will be red phase, 1 bedroom will be blue phase, and another bedroom will be a yellow phase. Okay, there's no such thing as a house which use 3-phase equipment. All my life of doing electrical jobs, I saw only one household thing that is actually 3-phase. So mostly 3-phase is used for factories. Okay, so because factories need powerful motors, so they use all 3-phase. Okay, and it is not 11 kV. Okay, big giant factories are still using 415. Okay, 415. You see how you get 415? This is 240. Okay. Okay, it's 240 volts. Okay? But if you can measure from here to here, okay, it's 415 volts. Understand? Get it, huh? Remember this, huh? Okay. So in a single phase house like your fan, it is using 240. It's a 240 volt motor. But in a factory motors, mostly it's like this. Okay. Okay. So factory motors is mostly like this. Okay. So each of the coil got two phase going in, and there are three coils. Okay, that is the meaning of three-phase motor. So this can be as big as 2 classrooms. Okay, I heard the water board. Most of the water boards in bigger towns, they are as big as 1 classroom. Okay, but of course, Sarawak, we don't have very big town. If you got a bigger city like Kuala Lumpur, you'll be like 2 classroom big. That's just one motor, one motor per pump. Okay, so they'll be connected like this. So when I was teaching this subject, a lot of time when the exam come out, a lot of people say, "Oh, 11 kV and 275 kV are for factories." That's not true at all. Okay, I remember our voltages. I think I did send you the notes. Yeah, I'm sure I sent you the notes. Is from 11 kV in the power station, step out to 275, and then it goes down to Cebu, surrounding Cebu, which is basically the wire crossing UCDS. You must take a look at this. You see, when you're in electrical, you must take a look at electrical once in a while. When you drive out UCDS, you see the overhead lines, the big one. That's 132 kV. And it's bare wire, no plastic. The ones in your housing estate has plastic. When I was young in Kuching, there was no plastic. Okay? But the squirrels cause a lot of problems. Sarawak has a lot of squirrels, and squirrels between the nose and the tail is very long, so they cause short circuit. Of course, they'll die, but in between they will trip one whole housing estate. Okay, so it causes a lot of problems. So that's why the housing estate wires are now covered with plastic, which is a loss to Cisco. Okay, whenever you cover any copper or aluminum cable with a plastic, there'll be losses, huge losses. Okay, I'll show you after this a table to indicate the losses. Okay, so cables are always best bay. So in 11 kV and above is always bay. Okay, because it's quite far. The separation distance between the 11 kV cables are quite far. So squirrel cannot trip them unless it's a snake lah. So that's why going up 11 kV, sometimes you see nettings with sharp nettings. So the snake will not bother to go up that high. In the only place I see 11 kV, there are some places where they put plastic. Okay, in Semenjung is mostly plastic. Okay, they call it ABC wire. Okay. Semenjung means Sabah because Sabah follows Semenjung. Okay. ABC means aerial bundle cable. Okay. Sarawak tried this a bit, but they didn't like it because the losses are high. And when you have losses in transmission, it's Cisco that loses, right? So Cisco didn't like it. And then, but even worse for Cisco is it damaged faster. Imagine when you cover up something very hot. Of course, obviously, the damage will be coming faster. And then the transmission loss is quite huge, actually, when you cover up with plastic. Okay. Okay. So in all cases, mostly the three-phase machines are in factories. I've only seen one of all my installations so far, a case of a household with a three-phase aircon. Okay, most people don't, and it's terribly cold. The compressor is taller than me. Imagine I'm tall enough. I'm 5 feet. I don't know, 5 feet 10 or something. But the compressor outside the house is taller than me. Okay, that's what we call it 50,000 BTU aircon, Panasonic lah. So I installed that one. I mean, I installed the wiring for it. The aircon guy fixed the aircon. I have to supply him the cabling lah. Okay. So you can practically say in almost all cases, household things are single phase. Okay, even rich man's house, super rich man. I heard one of the biggest house in Sarawak is the I don't know, who's the guy, the Sin Yang, okay, in Miri. Okay? He has his own flyover. Someone told me, I never seen myself. But even his house is three-phase house, but all his equipment are single-phase. Maybe he has a three-phase aircon, but I'm not sure, because my experience with that three-phase aircon that I installed is terribly cold. You can't even stand. Okay, so the guy, the owner, have to keep offing it. Maybe put a. I see he has to off it all the time because it's too cold. Okay. So remember this, for your assignment and your exam, you need to know all this stuff. Okay. This is your major question in your exam, and your assignment is 20%. It's all about these things. You can put all this stuff inside. I'll send you the notes later. Okay. Okay. So basically, Cisco, especially some regions like this Sri Aman, because this portion of Sri Aman is actually Cisco region is under Syrian. So it's Cisco Syrian that approve my wiring. If my wiring is good enough, then only they give me the power. Even though I already pay 7,002, they just won't give me the power unless my wiring is good enough. So this is what is satisfactory for Cisco. So at least next time you do this thing, you know lah. They are very strict in seeing that your electrical is good enough, then only they will supply the power. Okay. But the thing is that I waited 1 year for Cisco to give me power. Then I was thinking, because recently my project I had to use a lot of Arduino, and then we did this last few days. Just use a relay Arduino, and we power a 100-watt bulb. Okay. Why can't I just use a rectifier, single phase? Because I already calculate that the current per phase in my pump, even though it's three phase, is only 3 amp per phase. Okay. So with 3 amp per phase, this Arduino relay can take 10 amp. So I can use just 3 relays. I first rectify the incoming, I rectify to DC, and I use this and switch on every 20 milliseconds. Every 20 milliseconds, I switch on one of the relay, and one relay go to one of the phase. I can run a 3-phase pump. There's no problem getting 3 amp out of a single phase. Single phase homes, I think is typically somewhere between 20, 30, 40 amps. Okay, if you on all the aircon, it will be about 40 amps. Okay, so 3 amp is no problem at all. Okay, it's 3 amp per time, you see. Every 20 milliseconds, you are a red phase, 3 amp. And next 20 milliseconds is yellow. Next 20 milliseconds is blue. Okay, so you can run a 3-phase motor that way. Instead of waiting 1 year for Cisco to give me the power, spending 7,002. But by the time I look at this, because I didn't think of this, I just thought of this after the Cisco already given me the power. But I did try looking for it, because I thought if this is definitely possible, people should be selling this. I searched Amazon, I searched all the websites. Nobody's selling it. The only thing someone is selling is they use single phase to run a motor, and the motor runs a 3-phase generator, and that will power this pump. But it's quite expensive, beyond my budget. Okay, I have to order it from Amazon, from USA, flight, all this is too expensive. Okay, but this one, using an Arduino, 35 ringgit, plus the relays, the relay is 1 ringgit each, It's that cheap. So 35, 36, or 738, 38 ringgit, plus a few wires, I can get a 3-phase motor running with single phase. Okay. Basically, this paper I just wrote last Wednesday are saying that, university research in developing countries like Malaysia, we should be focusing on this kind of thing, because there are a lot of people who are poor. Why are we doing, like improving handphones and improving computers and stuff like that? We cannot compete with Western country people, the developed country people like Korea and all that, Japan. They got huge companies like Sony, Samsung, with huge budget. Billions of budget. How can we in Malaysia compete with them? And even if we get something really working, improvement in handphone. You think they want to accept our idea? We got copyright of it. They're the one. See? So we should be doing this kind of thing because the people, there are still a lot of people. There are 4 villages around this kampong with no water. Imagine how hard it is without water. It's really terrible. I went there first time because someone told me they needed, they want water. They got power, so they installed. Someone contributed some, some lamps and fans. Asked me to install. So I was there until evening. I had to go to the toilet. No water. Wow. Okay. And I talked to our research department. Maybe we can have a grant to give them water. So it's been what, 2 years? Maybe it's fine. Yeah, more than 2 years. I'm working on this. But 1 whole year of that is basically just to wait for Cisco. Rewiring. Not small rewiring. I'm talking about each time they tell me reject, total rewiring. Okay, I got to pull apart what I did before and redo everything. Massive job each time. And finally, it's like this, then only they approve. So that's a Cisco meter. See, they won't give a Cisco meter until the wiring is to their satisfaction. You see, one of the things that is a bit crazy, this, I don't know, I think my cursor cannot be seen. You see, I put the blue arrow pointing to that conduit. GI, metal, GI, carbonized iron. Why? They want it like that. You have to follow. That's the ground wire, the earthing wire. Why they want GI conduit? They say plastic cannot. Must be GI. Okay. What to do? Just your spec. You got to follow. There's no logical reason for it. They want it like that. Yeah, and then they want an earth chamber. Is there any purpose for earth chamber? I cannot see. Okay. They want an earth chamber. You have to buy an earth chamber at the bottom there. Why? You just have to follow. Okay. So some of the specs are quite illogical to me, but you just have to follow. Okay. So with Adreno, I could have run. I could have not this status quite well. Not better than 7,002. Imagine the saving. From 7,002, I had to spend just 35 and 1 relay, 3 relays. 35 plus 6 is 78. They don't sell 1 relay, so you have to buy 4 ringgit extra. 1 relay, 1 ringgit. So you buy 4 extra relays. So 35 ringgit for Adreno. 1, 2, 3, 4. 39 ringgit instead of 7,002. Imagine it's a bit of technology. You need a rectifier, probably another 35 ringgit. Okay. So 70 ringgit. So 70 ringgit, I could have saved. I could have got this working instead of spending 7,002 and waiting 1 year. So sometimes high tech is important, like in this case. Instead of waiting for Cisco to give me the power, I could have solved it. But actually, I only came across this recently. I didn't think about this because I thought, if this is so simple, why no one's selling it? There's nobody in the market. I searched very long time. I searched Amazon. I searched also websites. Nobody's selling it. I don't know why. Because probably nobody needs it. That's what my thinking. People who want 3-phase are quite rich, so they don't need to run a 3-phase motor from single phase. That's my thinking. Okay. Okay, so and then this is something interesting. You see this picture, figure 4 here. Initially, we're using a grinder, a grinder to cut the pipe, 1.5 inch pipe. You can see the mess at the bottom, with the middle row bottom. It's very messy. And then the whole, this is my school in Kuching. I have a school in Kuching where we test out the whole thing. We cannot build the whole thing in the kampong. The kampong is 2 hours from Kuching, 2 hours from my home. If we build in the kampong, we're missing 1 screw. We got to drive 4 hours, 2 hours back to Kuching, 2 hours back there, which is not practical at all. So you can see on the figure 4 the 2 blue tanks. Figure 4 left, the 2 blue tanks. The first the first tank, the rightmost tank is represent the river, okay, and the left tank represent the tank in the pump house behind the Dewan Suara, which we finally built. So we test out the whole thing in the school, my school in Kuching, before we brought it to Kampong. Okay. There's a sensor, there's a sensor. You see the figure 4 top right. There's a sensor that detects the pressure. It has, like the toilet. You see the figure 4 right bottom, like the toilet float. When the water is high, you build up pressure in the pipe, going in from the river. So this sensor will cut off the power. It just cut off all 3 phase. Yeah. Just now I was talking about cutting the pipe. Initially, use a grinder, and then one of the students in my school, he's working in Western Digital, he suggested this red tool in the middle top. Okay. Wow, with that you look at the difference. See the middle second picture is so perfect cut compared to grinder. Okay, so with a grinder you can't even put the fittings in. You have to, after you grind, you have to go and use a pen knife to cut off all these burrs. Then only you can fit into the fittings. Okay, this is a kampong. You can see a location of the river here. That empty spot, that's a location of the river. So originally we want to put the pump house near the river, but that house over there is not very cooperative. So the kampong decided to give me the community hall, Dewan Suara, just behind the Dewan Suara, kind of location. So this is the pump, the connection, and the circuit we built to run the pump. It's an auto train circuit. Okay. Okay. This one is an experiment I did in the swimming pool. In Kuching there is they call it Tapiang Gelanggang. It's the place where Pandalina, I think that's her name, right? The silver medalist in Olympics. That's where she does a training. It's a diving training place. So it's 20 feet down. When you're diving, you cannot be just 10 feet. Normal swimming pool is 10 feet, the deepest point, right? This one is 20 feet. So I use an electrical conduit, 2 conduit. One conduit is 12 feet, so I joined 2. So it is 24 feet, but I cut 4 feet off. I put it to the very bottom of the pool, and there's no water coming out. That's crazy, because when we go down even 10 feet, I think some of you might have gone to swimming pool, you dive, go to the deep end and go down 10 feet. Your ear is very painful, so it's very high pressure down there, right? But it's 20 feet, so it should be super high pressure down there. I've never been 20 feet down. But there's no water gushing out. Because initially my planning was, we built, you see the original design location of a 9,000 liter holding tank. And then going up to the rest of Kampong is another 10 feet. Okay. So we thought the pressure at the bottom of the big tank that we're going to, the holding tank, the pressure at the bottom will push out the water down 10 feet. From this experiment, we know that it won't happen because there's pressure down there, but nothing about here. Okay. 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 So we use this commercial engine pump to fill up the pipe, because you have water pipe, you need water in the pipe. Okay. So if there's no water in the pipe, you just air it, the pump cannot work. So we have to fill up the pipe, 1.5-inch HDB pipe with water using this commercial engine pump, and also to prime the pump. The pump need to be primed. This is how we prime. This is from a commercial engine. Figure 11, you see the orange piping. So the orange piping pipe, the garden hose, they fix it there. Initially, I was holding, actually a few hours I was holding last Saturday to prime. We got to pour water into this bottom, the impeller portion. Then only the air in the pipe will be got rid of, then only you can pump. Okay, so holding it with super high pressure, this is a 4 horsepower pump, very powerful. Because once in a while it'll be very powerful and then stop because of air. Yeah, start, stop. But so finally I did this lah. I just use a 2.5 mm square wire, use a vice grip plier to fix it there. So auto, I don't need to use my strength anymore. Okay, so I just, and then this is the high pressure water that goes up to the kampong eventually lah. Okay, so the kampong folks, yeah, this is the incoming. That's the problem last Saturday because I put the incoming here below to tanks, but somehow it went off. So I got to go tomorrow and fix that. It slipped off. I don't know how that happened, but I got to fasten it and put some weight on the incoming, so that it's always below the water. So the reason we had problem last Saturday with this priming is because sometimes this incoming pipe was above the water. Okay, so you're sucking air. So I built some weight, the normal bata, the red bricks. I put 4 together and cement it up in my house, and then tomorrow I got to bring it there and get it to hold down the incoming portion. Incoming portion at one-way valve. So the one-way valve to prevent the water leaking out if the pump is not on. So kampong people built this roof for me. One day I came, wow, they did this for me. Okay. Okay. Of course, we need a very strong flow because the tank that you see here is 9,000 liters. That means 9 tons. So a normal flow would not be able to hold it. So they built a special, the kampong folks built for me, a special strong flow. So most of the time, actually, the people who help me, because I got FIP, but FIP is only FIP 2. Mostly they come and help. Yeah, Dylan was different. Dylan helped me FIP 1 and 2, but mostly it's my 2 children who helped me in the project. Okay. Okay, so this one we finally released the water supply to the kampong last Saturday. Okay, the first people to operate the system was this gang. Okay, the kampong gang. Okay, let me show you another one. Okay.
Okay. Tengok itu. Itu kawan itu suka aja. Itu. Oh ya. Come. Go inside and on the second one. Sorry, can you hold it? No, I did something else.
So Kampung people never had water so high pressure before in their life. So they're very excited with the high pressure water here.
Itu dia pasal. Memang aja barang jenis on. Memang aja jenis on. Dia aja. Dia aja. Yang warna merah ya.
Okay. Okay. Wait a minute. Okay, I don't see Dalton. Oh, yeah, Dalton's here. Okay. Well, this class is now to repeat before. Okay. Okay. Just to remind you, this one I need to submit in a semester. This is your attendance. Okay. Oh, sorry. Oh, that's okay. 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 So this is your attendance. Online attendance like this, huh? No more signing. Okay. So remember, if you don't attend class, like I told you, Dalton was not here just now. Last time one student got kicked out of UCDS because he practically didn't attend any class for 2 subjects. Okay. So for this time, the attendance is like this. Okay. So every class I need to get a split screen like this. Okay. 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 I'm still on the first topic. So, can someone answer me why the power stations are producing at 11 kV and not other voltages? It's actually the actual voltage is between 11 and 15 in Sarawak. Okay, some mostly 11 and some up to 15 kV. So why is it 11 to 15? Anyone can answer? Definitely one of the question in your exam. Anybody knows? You should know by now. I did tell you before. Okay. Okay. Okay, this answer. Okay. Okay. This is the reason why you cannot have more than 11 kV. Optimally, you see, from the power station like in Bakun, okay. So from Bakun is 11 kV, and it is using a transformer that step up to 275 kV. Okay. Optimally, if you produce at 275 kV, actually it's much cheaper, you know, because 11 kV, the voltage is low, the current is high. When current is high, you need bigger wires. Okay. So your generators need to be bigger. So actually, it's much cheaper to build a 275 kV power station. Your wires will be very thin. Okay. But the humans cannot work inside them. Okay. So the reason why all power stations are producing between 11 and 15 kV is because of this. The humans cannot work in them. It's too dangerous. Okay. In fact, I went for the campaign speech by Adinan Satem, our former chief minister. Standard, he'll come in, he starts singing all these songs. He sang 2 songs before he starts speaking. There's a huge crowd line Pullman Hotel here. Somehow, I was a lecturer in Unima, so they invited me to go. So he was saying, these people around here, it's a huge dam, Bakun. But people around here have no power. I disagree with this. I'm going to solve this. So what he's solving was basically get the federal government to give Sarawak 500 million to put solar panels all over the kampung here. Okay. But I think that's a bad solution because normally solar panels fail after 2 years. There's statistics. Okay. I talked to a lot of Cisco people. They say standard after 2 years, all the solar projects in Sarawak fail. I think I told you that the largest solar project in Sarawak is in Pario. Okay. Okay. So Pario has the largest solar power project. You put all this in your assignment and your exam later. Okay. There will be your biggest question. Basically 20% will be on this topic. Okay. But I talk a lot about this because I get a lot of people, I see a lot of people who don't know this is a fundamental thing. How can you call yourself an electrical engineer when you don't know this basic fundamental knowledge? And a lot of people, I'm talking even lecturers, who don't know these basic things. Okay, so there's disaster. I mean, how can we produce electrical engineers who don't know the basic stuff? That's why I spent a lot of this class on this topic. Then you have to answer this in your assignment and your big question in your exam. Probably make it even 1.5 question. Okay, so that's 30% of your exam, final exam. Okay. So this project, there is a lecturer in UCTS who always go to Barrio, Gary in IT department. He told me it's pretty much failed. I think last time I met him which is quite a few months ago. Every time I meet him, I ask him how's Barrio. I built the micro hydro in this place. When I was building this micro hydro for Unimas, I basically had repaired the project. They built a micro hydro and it was a mess. It was a failure project. And then they asked me to go and repair it. So I repaired it. But at that time, they were building the solar, this largest solar in Barrio. And after that, I didn't go there. That was in Unimas probably 2015. I think they released it only 2016. And Gary used to go there, and he told me it is pretty much a failed project. He talked to the CESCO staff in this place, running this place, and he said he doesn't have much hope for it. Basically, it's a totally solar project, totally solar PV, and then it was built by Dato' Chu. Dato' Chu is a Cebu guy, okay? And then he handed it over to CESCO. CESCO has a lot of smart people. CESCO has a lot of smart people. You know why? It's, since the beginning of Sarawak, it's pretty much the largest employer in Sarawak in terms of engineers. Definitely the largest employer of engineers in Sarawak. So all the smartest Sarawakian, when they come back, where else to work? CESCO. I came back in 1993. I work in CESCO. There's no other place to work. Okay, so pretty much all the smartest people. The guy sitting next to me was in CESCO control room. Was Sarawak's number 2 student, straight A from 6. Okay, now from 6 straight A is superhero like in Malaysia level. Okay, especially older. I don't know about now but those days you want to get straight A from 6. Yeah, definitely Malaysia top. He told me he's Sarawak number 2. I don't know how. Okay. So these are the kind of people in CESCO. So CESCO, a lot of very smart people. CESCO knows solar project will not work in Sarawak. Okay. So what CESCO did as soon as they got it, they didn't release the energy to the kampong. They put 2 gensets there. The Barrio is 1 megawatt. Okay. Barrio is 1 megawatt. So when Dr. Chu handed over this project to CESCO, straight away they put 2 big gensets, 1 megawatt. I think it's not exactly 500 it's a different side, but the total is 1 megawatt. Okay, I think they put 3 gensets, if I'm not mistaken. I remember right now. I talked to the people who are installing it. They're working for, they're contractors of CESCO. Okay, not CESCO, they were the contractors of CESCO who were installing the genset. Okay. So if the solar not enough power, the genset will work. They take probably just 2 months to build the genset. And the solar cost 20 million in Barrio. 20 million for the solar. And a genset, someone asked me to quote one big newspaper in Kuching. I think they wanted my quote just as a backup. So they want to give a job to someone else, but they asked me for a quote. So my quote was just about 100,000. Okay, just 100,000, definitely enough to a genset. 100,000 is definitely enough for the whole Barrio. Okay, this solar is 20 million. And it's already failed after 2 years. Gary, who goes there all the time, he said all the batteries pregnant. Okay, come on. Okay, He's not old. Last time I met him, which was quite long ago, I don't see him now. He was in my building. I think he's not more in my building 6. So I used to meet him before. But he told me this 10%. Last time I met him, he told me 10% of the batteries come out. Okay, that means pregnant. Okay, that means spoiled, basically. Okay, and these batteries, there are 700 batteries. You can put all this in your assignment. There are 700 batteries. Okay, there are 700 batteries at costing 12,000 each. The battery. Okay, how much is that? I mean, you see, just the damage alone. That's last time I met him. It was just quite long. I think he's promoted to some higher position. I don't know. I mean, Gary. Okay. So 70 batteries is gone, right? Last time I met him. Imagine that. 840,000. This kampong has just very few people. I think you know Adam and Fabian. They're from Barrio. They're not, I mean, the power that Unimas Micro Hydro gave to this kampong was not in Adam and Fabian's longhouse, but the Unimas Micro Hydro gave power to Perampo A and Perampo B. I think Adam and Fabian are living in another kampong, another longhouse, but in Barrio. I think some of you might know Irene. Is much senior than you. Irene is from one of these longhouses that I gave the power to. Okay. But imagine this, 840,000, and my quote for the Sarawak Tribune genset was just about less than 100,000. Sarawak Tribune is a big building in Kuching, and my quote for their standby genset was just about less than 100,000. Okay, less than 100,000 can definitely power the whole barrio. This one is just battery, which is already damaged now. Okay, after 2 years of operation. So you can see how ridiculous the solar projects are. Okay, it is. I mean, you see the numbers. It doesn't make sense. And that's why all the big people say the same thing. You see, Sarawak is especially bad for solar. You know, I met the solar chief. He was my student. He got a master's already from UTM. He's from Kapit. But he was working in oil and gas for a long time, and then he moved to Cisco, and then he was assigned to the solar department. And then he came to my house because someone wanted to do a kebajikan, charity for one kampung nearby here. So they bought a solar panel. I think a few solar panels. And I said, can you come to my house and show me how to connect all this? And so he came. And then I asked him, how solar? Oh, not good, solar. Too much cloud cover in Sarawak. You know what? Now he's the boss of the whole Cisco Solar. And now I met him also. I mean, not recently, but probably a couple of years back. He's already the boss of the whole solar. The house solar. Oh, solar very good. He changed because now he's a boss. Okay, he has to change. Okay, so you see, Sarawak has a very bad situation for solar. I show you. You see, on the way to Barrio, this is what I see. You put all this in your assignment. Why solar is not a good option for Sarawak? Okay, let me share. Okay. Okay. Yeah, this is again print screen this for your notes and your exam. Okay. Why solar is not for equatorial countries? Heavy cloud cover, high ambient temperature. So PV doesn't work well with high ambient temperature. Qatar is kind of a rich country. I think. Yeah, my former student had been there. Yeah, what's her name? John, talked to him in my last class. I forgot. Never mind. Qatar is quite a rich country, so they decided, hey, we have sun, let's do solar. It didn't work because the temperature is too high. Okay.
Sir,
then,
if solar power is not good for equatorial countries, then what about the floating solar that Sarawak Energy has proposed to build in Batang Air Hydro?
Sorry to say, that's for me is definitely a big mistake. There's another huge floating solar in Singapore. You see, sometimes engineering decisions are made not because of engineering. There are political reasons. Can't tell. I don't know. There are a lot of bad stuff going on. It's not always a good reasons. If the world doesn't work, if the world is all good people running the world, there will be no poverty in the world. Okay, the poverty, the starvation, pretty much more than definitely about 3/4 of the world is poor. This should not be the case. It's all because there are bad people who are in power. Okay, so if you want, you can just go to. I wrote a paper about this. If you go and type my name and Google Scholar, this is how you find papers on Google Scholar. Let me show you. Let me see. Okay. Okay, let me see. Okay, you can see my screen, right? Can you see my screen, Google Scholar?
Yes.
Okay, so you just click Google Scholar. You just type my name. And you can find my papers. Okay, some of my papers. Yeah. This one, photovoltaic versus micro hydro for rural non-grid areas of Sarawak. Okay, I wrote a paper, and then when I was in Unimas, at the time I was teaching a lot of CESCO stuff, so they gave me all the feedbacks, the real feedbacks. Okay, not the politically correct feedbacks. The people working in the solar department, some of them are my students, and they told me all failed. All the solar projects failed in Sarawak. Okay. So you can read this paper if you want to get more information. Solar is good for countries without cloud cover, like China, India. I was in India somewhere, when was it? I think last year beginning, between January to February. Yeah, that's our semester break, right? January, February. I didn't see a cloud at all. The whole time I was there. That's perfect for solar. Sarawak, when you don't see cloud, it's probably a few days in the whole year that you don't see cloud. Okay, every day there's cloud, and you see this is what cloud does. Let me show you. Yeah, sorry. Okay. 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 You see, this is my trip to Barrio, because from Miri to Barrio you have to use a small plane. This is a small plane. So yeah, this is a trip to Barrio. You see, the cloud is not just a lot; it's very thick. You know, from the top to bottom of this cloud, it's a huge mountain. You know, so what can reach the ground is very low. Okay, that's why we're not so hot in Sarawak, because whereas in countries, even though we are in the equator, which is the closest to the sun, we're not as hot as Arab countries, because we've got thick clouds sheltering us from the heat. In Arab countries, it can reach 50 degrees centigrade. Ours maximum 27. Because of this cloud now, this cloud keep us a bit cool. Okay. And you look at this. Okay, this is a huge cloud. This is like a giant mountain. I think no mountain is as tall as this. That is the thickness of the cloud in Sarawak. Okay, this is a small plane we use to go Barrio. It's interesting using the small plane because you can see more things. And when you take an international flight, you don't see much of this too much. You see this? This is on the way to Barrio. These are some oil palm plantation. These dark spots, we got solar. Okay, the bright spots you can get solar. Maybe you put there, but the dark spots, how? Okay. In countries without cloud, it will be bright all the time. So at 7 a.m. you got solar power. 7 p.m. no solar. Imagine Cebu, sometimes 2 o'clock, very dark. What solar are you going to get? You do a few solar panel, okay lah. You do for one long house solar panel, okay lah. It's not so much power, right? Imagine we connect direct to the grid, 1 gigawatt. Around Cebu we put 1 gigawatt. 2 p.m. dark. That darkness, I think 80%, because I put it in my paper also. Hawaii had a case. Hawaii is pretty much like Sarawak, right? A bit equatorial. I think they're not really equator, but maybe tropical. But they have a lot of rain also. So one time a thick cloud come in Hawaii. That was a famous case lah, and almost destroyed the whole grid. You know why? Because their solar. They were quite heavy in solar in Hawaii. So one thick cloud cover came during the daytime, and it took out 80% of the solar power disappeared just like that. Imagine, in Cebu, you put 1 gig of solar panels, 80% gone, is 800 megawatt. 800 megawatt gone, suddenly, within sometimes 20 minutes, the cloud cover can come, 20 minutes. I've seen that suddenly, because I dry my clothes outside in my Cebu house, and then it's still bright lah, no problem. But now online in my house, and then my clothes are outside. Suddenly, within 20 minutes, raining already, dark cloud. Okay, 80% of the power gone. That's 800 megawatt. Okay, I tell you, in Kuching, we have combustion engine power station. It's about 20 megawatt. 20, It takes 1 hour to start up, Let me write down. This one you definitely must put in your exam. ICE. Okay. So when you have 80% suddenly missing, you need to start up other generators to pick it up. If not, because of the supply and demand must be the same. Okay. If it's not the same, it causes a lot of problems in frequency, voltage variation. You can trip the whole Sarawak. Okay. Always the demand and supply must be the same. Okay. Suddenly 800 megawatt. That means you don't have battery, right? In Cebu, 1 gigawatt of solar panel, you don't have battery because battery is too expensive and it damaged it within 2 years, right? So we don't have battery. The solar panel in Cebu, we say connected directly to the grid. Suddenly, cloud cover come at 2 p.m. 80% gone. Okay, I was in control room. That's my job last time. Hey, kurang tenaga di Cebu. This is in Kuching. Kuching, can you start 2 more? They only give me 20 megawatt. Coal, can you start some more? I call Muka. I call Sejingkat, and I call Belingan. Start all your engines. Cebu suddenly down. They give me power 8 hours later. What happening? 8 hours Sarawak blackout. Okay. Gas turbine in Bintulu. Okay, start all your engines. Bintulu is now very huge now. They can probably give, I think they can give 1 megawatt extra. Okay, it's about 45 minutes. But 45 minutes Sarawak have to be down. Okay. This one is good lah. Hydro is just 20 seconds. As long as you got water flowing down the pipes. The pipes are called penstock pipes. Okay. Okay. So if water is already flowing down the penstock pipes, they can shut off the water. But in certain cases, like in Bakun, they stop shutting down the pipes. Okay, so the water is always flowing down the pipes. The problem with water always flowing down the pipes, the turbine will get damaged faster. Okay, because it's not just water flowing down. Water also can eventually damage the turbines, the propeller, you know. But sometimes the water will have small stones and bubbles. Air bubbles can damage the propeller, the turbines. Okay, air bubbles pump and then they make a small hole in the propeller. Okay, so if water is already flowing down, which is happening in Bakun, to give power is just 20 seconds. So how do they give power? You see, it's running freely. The turbines are running freely, right? You want to give power, you just put DC in the rotor. Okay? So the rotor, which is turning, you make it electromagnet. Immediately the stator coils will give power. Understand? Okay? Let me write down. Because a lot of people don't get this. Okay. Okay. So if you know what you put your exam and your assignment, if you just put DC in the stator, the rotor coils, the rotor coil is an electromagnet, so it becomes a magnet, right? So within 20 seconds, the stator will produce energy for Sarawak. So hydro is super special. No power station can beat hydro in this. That's why, for me, working in Cisco, of course we should use hydro. I mean, there are a lot of complaint about hydro. I mean, by stupid people. I met one of the guy, one white man. What is his name? Was one of my university students working for him. I don't know, some Switzerland guy who's agitating all the people in the kampong to fight the hydro projects. But me, as a Cisco staff, I can't see anything better than hydro. It never failed. I got one guy working in Batang Ai for 21 years. It never failed. Now, when I call this power station, okay, can you start one more? Yeah, down lah. Set number 2 down. Set number 3 down. Maintenance. This one also always maintenance. This one always maintenance. Hydro never maintenance. 21 years just jalan saja. Because it's so simple. You got water coming down the penstock pipe. You got turbines turning on top of the generator. It's nothing to fail. There's no parts to fail. You see, your car engine will always fail, right? Because you got pistons moving here and there, so many mechanical parts here and there, always fail. Okay, but the hydro is just so simple; it just doesn't fail. Okay, and then the complaint I talked to that guy on Facebook because my university student working for him, Bruno Mesa, that's his name. But people say this guy already died. Bruno Mesa. So one of my university students working for him, still working for him. People say he already died. So his organization, I don't know who write the reply to me. My student write something and then I reply, if we need hydro, how can we don't use it? Hydro no good. He said, say ecologically no good, and then I said, but we need hydro. It is the best form of energy for Sarawak because we got a lot of water. We got the most water in the world, the equatorial. Okay, we got 6 times more water than the whole northern hemisphere. The northern hemisphere, I'm talking about Europe, America, China, Japan. These are most of the developed countries, right? We got 6 times more water than that. So why are we not doing hydro? It's just like, God gave you something you don't want to use. I feel that's bad. I mean, I always teach my children that way. If you find some coin in front of you, what God give you, my children say, teacher, cikgu, SRK, okay, right? SMK, check up. Bagi cikgu, so what are cikgu going to do? That one you see in front of you is for you. See? I mean, that one God gives you, see? If you see one time my son found 150 ringgit on the parkway near we are going to Kopitiam. That one God gives you, you must keep. God give us rain, we don't use rain. You want to use solar, which is not meant for a country, it is meant for a cloudless place, which is cool. Okay? Cloudless not enough, Arab countries are cloudless, but it's not enough. It must be cool also because solar panel cannot stand the heat. Okay? So solar is basically not for our country. It might be, even then I'm not very sure, it might be good for Australia, which is cloudless and cool, and California, which is cloudless and cool. But I saw some data, someone did a research on the real feasibility of solar in California, which is like perfect for solar. Okay, they have, I think there's more clouds in California. Okay, now there's a song. It never rains in Southern California, something like that. Okay, but all these lah. Okay. It really never rains there. And then one of my relatives is working there now. And then one time it rained recently. And then the people see puddle on the road. They go past the puddle. They never see the puddle on the road. That's the kind of place you can build solar. But someone did a real deep research on California going fully solar. The numbers are crazy. It takes more than the US GNP, a few years of US GNP just to buy the batteries. And that battery will last 2 years. Okay, you see why batteries last only 2 years in Sarawak is, let me write down. Okay, all batteries need less than 25 degrees. We never get this, even on our closest. I check our coldest part of the year is like December, Christmas time, very rainy time is still higher than this. But batteries need this. So in colder countries, batteries can last longer. Like the solar batteries, let me show you solar batteries. Okay, these are solar batteries. Lead acid solar batteries. This is one used in Sarawak. 12,000 each. 12,000 ringgit each. These are the batteries I told you Gary told 10% has already been damaged. I think I met Gary the last time, 1.5 years ago. I meet him here and there in the university, but just hi, never get to talk to him because it's no more in my building, I believe. So 12,000 each, 10% gone. 840,000 just gone up like that in 2 years. 840,000, you can buy genset for I think half of Kuching. I think so. No, maybe not half of Kuching. I think half of Cebu definitely can. Okay, 840,000. Okay. You just bring you can charter some flights to bring the petrol if you don't want to bring it by truck. Because I heard the road's not so good going to Barrio. And charter flights, it's still cheaper. Okay. I did a calculation. If you just use diesel genset in Barrio, even 20 years of diesel will never come to anywhere near 20 million. Okay, it's better to use diesel. Okay, I don't know. Another case is Australia. Australia is one of the largest source of coal in the world. Okay. Australia is one of the largest sources of coal in the world. They export to China. I mean, it's a huge continent, right? And somewhere, a few, maybe 10, 20 years ago, someone managed to screw up the politicians in Australia. Australia started doing solar, massive scale solar. Australia is very correct condition for solar. They don't have cloud fudge, right? So they did massive solar. Imagine Cisco doing massive solar. Who's going to pay? We lah. Our electric bill will our electric bill will go up. So what's happening now? After 20 years of playing around with solar, in Australia, the electric bill is super high. The old parents who don't have a steady income sometimes, they wear jackets in their house. They cannot afford the heat. They cannot afford electricity. The electric bill is crazy. I saw the bill is like 500, something like that. 500 Australian dollars for old parents, father and mother, grandfather, grandmother, 500 electric bill. Why? Because that dear Cisco is playing around with solar. Of course, they don't want to rugi, so they charge everyone for it. So our electric bill go up. You see, Sarawak right now is the cheapest electric bill in the whole Malaysia, but far cheaper than Semajong now. Okay, we start playing with solar, our electric bill start going up. Because Cisco don't want to rugi, they'll charge the customers. Okay, so it's a big disaster. I don't know. You must study this properly. You can read my paper. You want to know about solar. It's just not for us. But the government, not many people have been honest about it. See, my friend is a top guy on solar Cisco now. And I met him many years ago. He said, no good, too much clock over Sarawak. Now he's a boss of the whole Cisco solar. So good. I guess he got bought off. Okay. By the solar people. Okay. Actually, sometimes it might be even dangerous to talk against solar. Okay. Because there are too many forces that's trying to push solar. But you must see the engineering things. And then even in America, top, I met one guy who's a very top, you know, Professor Emeritus, okay, in US. He's talking bad about solar. In US, where the conditions are almost perfect for solar. a long speech about 1 hour plus. He's a professor emeritus in electrical engineering. So it's a very bad idea. Because they're intermittent, you see, solar and wind are intermittent. You cannot say solar kurang, no mind. You know what is happening in solar? In America, where they do a lot of solar, and in Europe also, when you got 1 extra gig of solar farm, the coal plant is actually running 1 extra gig of coal energy. Imagine that. You only spend like Barrio is only 1 megawatt. Okay, if 1 gig is much more. Imagine Barrio is 20 million, right? 20. It's just 1 gig. 1 megawatt. So 1 gig is 1,000 times that one, right? Wow. To the power 10. Okay. Using Barrio's numbers, okay? 1 megawatt is 20 million. So 1 gigawatt, 20 million times 1,000. Okay. Ringgit Malaysia, 2 to the power 10. How is that? Billion is 2 to the power 9, right? So 10 billion, 20 billion, right? No, trillion now. Oh my God. A billion is 6, 7, 8, 9 is billion. Yeah, okay. 20 billion. Okay. Imagine you want to put 1 gig of solar. If going by Barrio's number, I don't know what's the real figure, okay? Going by Barrio's number, which is 20 million, 20 billion. Bakun is only 8 billion, okay? And you only produce 1 gig, okay? Bakun is 8 billion. Uh, 2.4 gigawatt. Okay. Imagine 20 billion in Cebu solar farm using Barrio's number is 20 billion, and Bakun is only 8 billion, can produce 2.4 gigs. You see the cost, craziness, and at least this one can last pretty much forever. I mean, at least going by Batang Ice, which is much before you guys were born, in early 80s, they started till now, not even 1 failure. Okay. Mostly hydros, they last pretty much like forever, more than human lifetimes. Okay. And it's totally free. You have no input at all. It's just keluar one. There's no business like this in the world. Okay. You know how much Bakun make if using our electric bill, we are paying 1 kilowatt hour 0.35. Okay, this is our electric bill in Sarawak. Okay, so 2.4 gigawatt is 2.4 times 10 to the power. Okay, just 10 to the power 9 lah. Okay, divide 1,000 times 0.35. Okay. You get this calculation, huh? You put all this in your assignment and your exam. Okay. This Bakun, what Bakun makes. Okay, you can see the calculation. So this is 840,000 per hour. Okay, per hour. Times 24 hours per day. times 365 days per year. Okay. In 1 year, if Bakun, people are paying Bakun, they don't pay, you see the big factories, they don't pay as much as we do as householders. The big industries are given cheap electricity, so they can come here, set up their factories, and then they can employ Sarawakian people. So when you go from these cities, you got jobs. Okay, so that's why they charge the big factories less. But if there's no subsidy for the big factories, okay, and they are paying, the factories have to pay as much as a household guy in Sarawak. Every year, Bakun can make 7 billion every year. How much they have to pay? Gaji for the people inside, the payment for the people inside. How much is that? Okay, make it 10 million, which is too much, I think. 10 million is way too much. I think even 5 million will do. Okay, 5 million. Okay, 5 million for 1 year's salary of all the people in Bakun, which is not many. I think USDS has much more people working than Bakun. Okay, so 5 million. You just minus 5 million from this. The rest is pure profit. There's no business like this in the world. Okay, you see, MLNG Bintulu make a lot of money. My brother was working there. When he was working there, he was not expanded like now. But when he left about maybe 12, 13 years ago, he told me he's making this much money, about 7 billion a year. But they have so much input. They got to buy the gas. They got to buy all the parts, keep changing. You see, when I was working in Western Digital, after Cisco, I worked in Western Digital. The facility manager was working in MLNG. So he moved to Western Digital, and then he quit. He quit because his actually reason for quitting is you're producing a lot of pollution, pure guilty. He don't want to have that karma on him. Okay, so he quit. And then he went back as a contractor to MLNG. Okay. And he said he cannot do anything. Every part changed. He don't know how to operate the system anymore. All become electronic. Last time they used all the pressure signals, all using gas pipes, to detect pressure. All this now it's fully electronic. You don't know how to do anything. So all these are part changing. All cost a lot of money. You have to buy all the gas. So there's a lot of input going to MLNG. This one is just pure profit. Pretty much 7 billion 300. 7,335,000. Okay, make it. You give 5 million, so 353 million profit, just pure profit. You cannot find business like this. Okay, so why are we not doing hydro? It's all politics. Somehow, some bad people couple of our politicians. Because every kampong in Sarawak has water. We should be doing hydro. I'm building a hydro in a very difficult situation because I got two of my regular, Thomas and Andy. Thomas and Andy, they are my YP. We are building a hydro in a place with no hills. It's very difficult, but we hope to succeed. It's just a river, and the river is in the middle. It go down and go up a lot. So it's a very difficult project, but I think we can make it succeed. So we got to put a barge in the middle of the river, tie it down to the river, and then get hydro energy out of it. So we don't have any height. We're using Archimedes screw. We got to be flat. This is difficult, but I believe we can get it done. Okay, I've been working on it very hard yesterday. That means every kampong, every village in Sarawak definitely has water. People won't live there if there's no water. There must be a river somewhere. And we are thinking even a small river we can get electricity out of it. Okay. So we should be actually focusing on hydro. And then this thing about what our former chief minister said, I remember September. So I don't agree. These people near here have no power. You know what is the excuse by Cisco people? You have one long house. This line is already 275 near the long house because they do this when I draw it quite far. Actually, it's right next to the power station. Okay, they step up to 275 kV. And then the kampong is just outside. You want to step from 275 down to 11 kV, which is the housing estate incoming, right? In your housing estate, the incoming is 11 kV. The transformer is 10 million. 10 million transformer just for one long house. It's a lost business. Cisco is not run by people who like to waste money. They're very shrewd. That's why they're a successful company. They are operated very well. Okay, they never waste money. Okay. I mean, of course, when I was there was some corruption, but we talk about it in the canteen. But I heard it's very clean now, because they clean it up. Okay. Brought in the right people to clean it up. So it's a very well-run company with a lot of very, very intelligent people. They don't make things like spending 10 million just for one long house. It's not I mean, I think a genset would be a better deal for a genset in the kampong. Supply the fuel or something like that. Okay. But I mean, but one thing I never really understand, there's already 11 kV here. Out of the generator is already 11. Join from there out to the kampong. I don't know why they never do that. I think the reason they never do that is this thing, that power station is standalone. Like one business unit of Cisco, of Sarawak Energy. They don't want to disturb the internal of that. Okay, so no engineers at Cisco come up with that idea. So here, let me show you. Okay, this is a Bakun Dam. So Bakun Dam has 8 penstock pipes. Okay, you can count the holes there. There's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then this is the pipes. Okay. And this is a turbine, the Francis turbine. Okay, this propellers now. Okay, on top is generator. Okay, here's where the generator is on top. Okay, so it's 8. You can see I made a numbers name under where it's on 8. And then here's the transformer, just outside. Okay, you look at the wires here at your left side. I know my mouse is not showing. On the left is the wires, and the right are the outgoing wires. You can hardly see the outgoing wires. You see the red, yellow, blue there? On top, you can see a small black line. That's the wires. Incoming so big. You know why? Because 11 kV. Remember, Okay, you might forget other things. You see, in electrical, there are 4 values, right? P, V, I, R. Okay. Electricity, wire size only depend on current. It's I. It don't depend on all this. So coming out of Bakun is 11 kV, going out is 275. When it's 11 kV, the M is very high. That's why the wire is so huge. The outgoing wires, you can hardly see it because it's 275 kV. Because P equals VI, right? So when you put the V very high, the I goes very down. Okay. The V is put out of 275, the I goes very down. When the I is down, the wire is very small, you can hardly see it. Okay, let me show you again. Okay. Look at this. I know you cannot see my mouse. Can any of you see my mouse? Can you see my mouse? Okay, you cannot see my mouse. Basically, on the left, the 3 wires on the left are the red, yellow, blue. Okay, you can see how huge they are. On the right, which you can hardly see a small black line, that is the outgoing wires, 275 kV. Okay, so that's why the right wires are so small. Okay, understand this, huh? Definitely put this in your assignment. I'll try to ask you all this. Probably put 2 questions, I think, better. What's the square electric system? Okay, that's 40 marks. Okay. So this is a 275 kV transformer of Bakun. Okay. You can observe this. You go to your housing estate. You go to your housing estate transformer. Some of them are old ones. The old ones you can see. The new ones they cover with cement because they're afraid if it explodes, hurt some upstairs. So now they cover with cement wall. In the old days, you can see some old substation which I think still quite a lot in Cebu. Their fence, the chain link fence, and they can see inside. You can see the incoming wire is just normally 11 kV. Outgoing wires are so big. Why? Because outgoing wires are 4 and 5, so they are so huge, and so many of them. Red, blue, red, blue, red, blue. If you count the incoming size, just 2, and the outgoing so many, definitely outgoing is far more surface area than the incoming, because wire size depends only on current. Okay. I know a lot of people don't know that. I talked to one Petronas manager, big guy. Okay. So to know this, he thought wire size should depend on power. I said no. It doesn't depend on power, it doesn't depend on resistance, only depend on I. Okay? Because of this. Get it now? Okay. This is very important. Definitely put it in your assignment. I'll ask you in your exam also. I don't know exam. Okay? I'll send you all these notes now. Okay? A lot of people don't know this basic stuff. That's why I'm teaching you this I know a lot of people don't, not the lecturers teach you this, so I'm teaching you this. Okay. Other than that, let me see. Power systems. So we should definitely be doing hydro. They last pretty much forever. And they are free. And one thing about that you must put in your assignment. hydro will attract investors. This is very, very critical. You see, the press metal boss, the owner, he's a KL guy, I think. I think so. I mean, people told me, I didn't verify. So someone told me he saw his house in KL. It's like huge house, like a senior boss house. Okay, I didn't see myself last. Someone told me. Okay, he's definitely the largest. I mean, Petronas is the largest factory in Malaysia. So press metal is probably the second largest factory in Malaysia. Okay, so the owner is in KL. Of course, with some local guys also become rich because of that lah. Okay, but he was not a rich man. I don't buy newspaper, but I sometimes pass by because I have a school in Kuching, and then near the school there's a bookshop. So sometimes I pass by the bookshop to buy some, marker pen or something like that. So I read the headlines. So, richest man in Malaysia. I say this guy is number 2. They always get angry with me. I read headlines. I never buy newspaper. So he is number 2 richest man in Malaysia. But I'm in Malaysia all my life. I mean, I know who are the rich people in Malaysia lah. Okay. I never see his name anywhere. Suddenly because press metal is number 2 richest man in Malaysia. Okay. Why? You see, she is just probably a millionaire lah. Okay. She go and write a paper. He write paper how to make press metal factory. So he cannot go to Maybank, or he cannot go to Bank Bumi Putra or Public Bank. No, you're talking about billions of money. They don't have that kind of money. So you go to World Bank. Okay. Sorry. Okay. So he go to World Bank. Go to World Bank and ask, I want a few billion. So I'm going to make a big factory in Sarawak, Samalaju area. They give him the money. You know why? They ask him, what's your source of energy? Clean bakun energy. Okay, proof. If they say you're going to use muka coal, which is actually the same grade, but Sarawak is mostly hydro. Okay, so he can put in his paper clean energy from bakun. They approve his project. If he say he's going to use coal, they reject. Why? The World Bank say you're adding pollution to the world. We don't want your factory. He says again, you use hydro. They give him the money, 2 billion. Because as bankers also, they want to make money. They can see this one is a good investment, so they give him money, 2 billion. Now he's second richest man in Malaysia. See, you don't have to be rich; just be slightly rich enough to afford to pay for the proposal paper. He got the money and he becomes rich. Okay. So like that, when you build your hydro, okay, this is a hydro that they're going to build in Sarawak. Okay. Maybe you can take a print screen of this. Wow, it is so small. Okay, take a print screen of this if you don't already have it. You'll probably find this in SAP website. But this is a plan, 13 dams. Okay? Because, some people say, take a print screen of this, Some people say, hey, you build all the dam, even Cisco people. Because I'm from Cisco, so I'm in the shopping malls here and there, all the Cisco stuff. Yeah, we're building all of them. I don't know why. We got enough power. You see, that was long back when they first building the dams. Now they don't talk about that anymore. Once you build a dam, you don't even need to advertise, to the investors. Investors will knock on your door. because it's so profitable. From a millionaire, you can be, I don't know, trillionaire or something. Okay, because the World Bank will approve when it's clean. Imagine Shell. Shell have never used Cisco energy, but now they're using. Why? Shell also want to look good to World Bank. So they say in Sarawak, you're using Cisco energy, and Cisco energy is 75% hydro. So we are clean company. See, they want to make their record look good. That's why they're buying from Cisco now. They never bought before. Just recently they start buying from Cisco. So it is very good in your social, your overall company's social standing. Okay, that's why they do that. It makes a difference, social standing. Okay, it makes a big difference. Your social standing is bad, people don't like you, your company is in trouble. Okay, so this one you must put in your assignment. Why people knock on your door? You don't even have to go out looking for them. They will come to your place and knock on your door if you have clean energy like hydro. Okay, it's a very, very important thing. Okay, so basically, my bottom line is we should never be doing solar. We should be doing only hydro because it's so perfect energy. Never slow down. Never sudden clock hour to shut down the power or anything like that. It's just stable and never fail. Okay. Okay, that's the end of class. I'll send you all these notes later. Okay, bye.
Thank you, sir.
Okay, bye.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.